All right. EM5. These are 3 questions that were used in the COVID era for test. So this is about as close to a test as you're actually going to get, at least for the FRQ questions. Our first question's on a mechanical wave. It says Washington sisters open up their own wave pool. The diagram, you see the wave here. L is shown, H is shown, and we're given some values. First question says, what is the wavelength? So, wavelength is a measure of crest to crest, which is literally L on this diagram. So, since L is 1.6, your wavelength is 1.6 meters. The amplitude would be from the equilibrium to the crest or equilibrium to the trough. H shows us crest to trough. So I want to take 1.70, cut it in half. That'll give me 0.85 meters. The frequency of the waves. So V is lambda F. They gave me the velocity of 3.38. I solved the wavelength of 1.6 in part A. Grab a calculator, 3.38 divided by 1.6, 2.11 hertz. And it looks like we're in agreement with the key. Period is 1 over the frequency. So 1 divided by 2.11, 0.474 is what I got. Based on rounding errors, that's acceptable. We're good to go. Question 2. Laser's laser. Student develops a special laser, gives us this frequency. Answer the questions that follow. Wavelength of the laser emitted in meters. C is lambda F. We're going to use, this is V equals lambda F. But what I did is, since it's light, the speed is C, 3 times 10 to the 8th. Uh, 3E8 divided by the frequency given of 4.59 E14 will yield 6.54, should be a decimal, E negative 7 meters. So 6.54, E negative 7, that one checks out. It's 654 nanometers. Energy of the laser in EVs, and then in joules. So I'll do B down here. Energy is HF. For joules, we're going to use 6.63 E negative 34. Frequency is 4.59 E positive 14. Calculator time. I got 3.04 E negative 19 joules. That's in agreement for part C. Looks like I did part C before part B. Alrighty. Not a big deal. Part B. 4.14 E negative 15, because for this one they want the answer with electron volts. Calculator is going to give me 1.90 EV. Yeah, 1.9. That's an agreement. Okay. Another student develops another laser. 475 nanometers. What is the frequency? We'll go back to C as lambda F. They gave us nanometers, so not a big deal. We'll do 475 times 10 to the negative 9th, because nano is negative 9. Calculator 3E8 divided by 475E negative 9. I get 6.315, so I'll round to 6.32. E14 hertz. 6.32 E14. And just like that, we're on to number 3. You'll definitely see this on the test, an energy level diagram. It's on every single year. We got 5 different levels of the ionization. My levels are given. The electron drops from 5 to 3. What is the frequency of the emitted light? So if I drop from 5 to 3, that is going to be an energy of 1.81 eV. The electron lost 1.81, so the light ray gained 1.81. E equals HF, so we'll go 1.8 equals 4.14. I'm using the 4.14 because all my energies are in electron volts. Calculator time, 4.37 E14 hertz. That's in agreement. Now it says electron in the ground state absorbs light, jumps to level 4. What's the frequency? So ground state's 1, and it leaps up to 4. The difference in energy is 10.54 EVs. So that means our light rate gained 10.54. I'm using E equals HF again. H will once again be 4.14 E negative 15. Go to the calculator. 2.545. So 2.55 E15 hertz. And we move onwards. Part C, 49 nanometers. Convert it to meters. Okay. 49 times 10 to the negative 9th equals 4.9 times 10 to the negative 8th. Boop. 4.9 times 10 to the negative 8th. Light reference in question C has enough energy to eject an electron in the ground state and thus does so. Determine the kinetic energy of the ejected electron. Okay. K equals HF minus the work function. I am going to use instead K equals HC over lambda since I have the wavelength. The kinetic energy is what I'm solving for. H 4.14 E negative 15. C is 3E8. Wavelength is 4.9 E negative 8. Ground state's the lowest level, so that's 12.3. All right, a lot of calculations here. I got 25.34, so that'll round to 25.3. Minus 12.3 is going to give me 13.0. That's good. Question E. Convert the answer from part D into joules. 1.6 E negative 19. This number is on your green sheet. Get 2.08 E negative 19. Oh, sorry, E negative 18 joules. I got 2.09. Looks like a rounding error, not a big deal. And finally, determine the velocity of our electron. So our energy unit tells us K is 1/2 mv squared. So 2.08 E negative 18 is 1/2. 9.11 E negative 31. This is the mass of an electron that is on your green sheet. Take my calculator, 2.08 E negative 18, divide a half. Divide 9.11 E negative 31. Take a square root. V comes out to 2.139, so that'll be 2.14 times 10 to the 6th meters per second. And there's the bell for the half day. Check, check. Success!